All right, so 3.6, the chain rule. So again, the chain rule is to take the derivative of a composition. So basically, it's our fifth operation. We know how to do addition and subtraction. Derivative of sums and differences are just sums and differences of derivatives. You just take a derivative piece by piece, right? Derivative of a product, you need a product rule. Derivative of a quotient, you need a quotient rule. But the derivative of a composition, you need the chain rule. So we know that it's really what it comes down to this is it says if I have f of g of x and I want to take the derivative of that thing, it's the derivative of the outside function, leave the inside function alone, multiplied by the derivative of the inside function. So that's really our technique. So number 3 asks us to it wants to use that dy dx is equal to dy du times du dx. It wants the elaborate notation for this one. But then after 1 through 8, we're just going to do this notation because I think it's so much easier, all right? So I'm going to do it both ways to make sure that you guys can see it. So what it says is number 3, it wants us to find the derivative, and it's kind of already pulled it apart. It says y is equal to the sine of u, where u is equal to 3x plus 1. So what they've done is they've already decomposed the function. So what they want to actually find the derivative is they want to find the derivative of this function where u is this function, okay? So really this function right here is being stuffed in that function. They've just hidden it with the letter u. Is that clear? Okay, so the way we find this, the derivative of this function with respect to x, because when I plug this in here, this is no longer a function of u, it'll be a function of x when you stuff it in. But we know that dy dx is equal to dy du multiplied by du dx. And all that is dy du is just the derivative of the outside function multiplied by the derivative of the inside function. That's all that really represents. So the derivative of the sine of u is cosine of u multiplied by the derivative of u. What's the derivative of u? 3. So this is equal to, and then I'm going to unsubstitute. I'm going to put this 3x plus 1 back in for u, okay? This u being equal to 3x plus 1 can go right here, right? Because that's what u is. So this is going to be equal to the cosine of 3x plus 1 times 3. Times 3. Or, I got a question. Can I multiply this 3 into this binomial? No, because the cosine is blocking it, right? Okay, so this is equal to 3 times the cosine of 3x plus 1 would be a better notation for that, right? All right, 3 one more time. Let's plug this in here and see what we get. Well, y would be actually the sine of 3x plus 1. That's really what they're asking us to take the derivative of. Does that make sense? Okay, so let's do it. Let's do it Newton's notation. This one up here. So I know that y prime is going to be the derivative of the outside function multiplied by the derivative of the inside function, right? Now when you take the derivative of the outside function, what's the outside function here? What's the outermost function? So what's the derivative of the sine of something? Cosine of what, though? What do you do with the inside function right now? Leave it alone, right? Derivative of the outside, leave the inside alone. So remember, that's what this says. It's the derivative of f prime, so it's the derivative of the outside function, but we're leaving this g function alone, right? Multiplied by, now we're going to take care of the derivative of that g function. What's the derivative of 3x plus 1? 3. And you can see that's why we get exactly the same thing. 21, we have e to the 5 minus 7x. So 21. If y is equal to e to the 5 minus 7x, what's its derivative? What would y prime be? Ah, it's so messy. So what would y prime be? Well, what's the outer function here? Yeah, so if we kind of go back to our trig function here. So when I had this function right here, you guys agree when you talk about a function like the sine function, its input is this thing, right? So this is the input, therefore that's the inside function, and this is the outside function, right? So when we're talking about an exponential, what's the input of an exponential? Yeah, the exponent, yeah. So this 5x minus 7 is the inside function, right? That's your u. You guys agree? So the outside function is e. How do you take the derivative of e to something? Yeah, it's the same thing, isn't it? What do you do with the inside function right now? You'll leave it alone. So the derivative of e to the 5x minus 7 is e to the 5x minus 7, right? That's the derivative of the e part of it. And what's the derivative of the inside? Yeah, derivative of 5 is 0, derivative of negative 7 is x is negative 7. So I'm going to rewrite this as minus 7e to the 5 minus 7x. Oops. 7x. Is that clear? Any questions on that? E is weird, isn't it? So remember, the derivative of e to the x is e to the x, right? So that's why it didn't change. 20. That was 21. 27. R is equal to the cosecant of theta plus the cotangent of theta to the negative 1. Okay, so now we have to remember our trig derivatives, right? Okay, so what's the outer function here? So the way I like to do this is I kind of like to collapse onto the function and ask what I hit first, right? So here when I collapse, you guys agree I hit the e first? Now, right here when I collapse onto the sine function, I hit the sine function first. Does that make sense? So what's the outermost function here? Yeah, this thing right here, this negative 1 power. Does that make sense? That's the outer function? Okay. The idea is if I was going to try to go inside and solve, this is the first thing I have to get rid of, right? Okay. So that means this piece right here is your inside function, right? This is the one you're not touching yet, right? You mess with the negative 1 first. So what's r prime? So what's the negative? Where's the negative 1 go? Out front, because it's a power, so power rule. And what does that power become now? Negative 2, drop it by 1. What do you do with the inside function? Leave it alone, yep, stays the same. Multiplied by, well, now we can worry about the inside part, right? Outside first, inside next. What's the derivative of the cosecant? Cosecant of theta, cotangent of theta. That's the derivative of the cosecant of theta. And what's the derivative of the cotangent of theta? Minus cosecant squared of theta. Alright, we might be able to clean some stuff up. Maybe. Let's see something. So I'm going to rewrite this. I know negative 2 means that thing right here, that this binomial is actually on the bottom squared, right? So this is cosecant of theta plus cotangent of theta squared. That's what that means. Is that clear? Can I combine this negative 1 and this binomial over here? Are they both to the power of 1? This entire binomial, what's the power up here? So that means I can take that negative 1 and I can multiply it inside, right? What's going to happen to these negative signs when you do that? Okay, so this is going to be cosecant theta, cotangent theta, plus cosecant squared of theta. Now what I'm hoping for is I'm going to see if anything factors and cancels. So what I'm looking at is the numerator, because the bottom's already factored. Does that make sense? It's already to a power of 2. There's nothing I can pull out any more than this because none of these things share anything. How about the numerator? Do they share anything? Does this does this factor right here have anything common with this factor right here? Yeah, what do they share? Yeah, single cosecant. So factor out a cosecant of theta. What's left here in the first term? Cotangent theta. What would be left here if I take one of them? You guys seeing that this shares something now? Can I cancel a little bit more here? Yeah, I have a cotangent of theta plus cosecant of theta. And I have two of them down here, don't I? Cotangent of theta plus cosecant of theta. So, if I cancel this, how many are canceling down here? One of them, right? Remember, with addition, order doesn't matter, right? So the commutative. Okay, so then this is going to be equal to the cosecant of theta all over the cosecant of theta plus cotangent of theta. Y is equal to x squared sine to the fourth of x plus x cosine to the negative 2 of x. That's interesting. I haven't seen that in a while. Okay, I can look at this. Let's talk about what these things mean first. So, sine to the fourth of x means sine of x times sine of x times sine of x times sine of x, right? So if I rewrite this, this technically is x squared times the sine of x to the fourth, right? Plus x times the cosine of x to the minus 2, which really means I have cosine squared on the bottom, right? But what's nice about the chain rule is we'll do it in a second. I'm trying not to forget, but here, maybe we can talk about it right now. Sometimes I go off on tangents. Sorry, it's not meant to be a calc joke. Okay, so y is equal to something as simple as this. You guys agree would have to be quotient rule? So if you wanted the derivative, it's going to be derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared, right? Is that clear? This goes away, so this is going to be equal to minus 1 all over x plus 5 squared. What's nice about this is also, since we have the chain rule, I know that I can rewrite that as x plus 5 to the minus 1, right? I like this because the numerator doesn't really have a function of x in it, right? So if I want to take the derivative of this, I know y prime, I can get away from the quotient rule here. It's much easier. That this power can go minus 1 x plus 5 to the minus 2, right? Times the derivative of what's inside, which would just be 1, right? And when you're still done, you get minus 1 all over x plus 5 squared. Okay, so what's nice about the chain rule is sometimes you can get away from the quotient rule. And I would recommend it if like the top is like just a constant and the bottom's a function. Like I would use this method. But if they're both functions, it's easier just to do the quotient rule. It actually simplifies faster. Because some people might even do this as well. If I have y is equal to like 2x plus 1 all over x minus 4. They might say, well, I hate the quotient rule so much. Why don't I just do it this way? And then I can just do the power rule with a chain rule involved. You see that now this is a power rule? But when you take the derivative of this thing, you have to do the negative one first, right? So the derivative of this piece right here would be a chain rule because you got an outside function and an inside function. So it's, there's a lot of ways to do these things now. So if it's already written in this form, then I'm going to use the power rule. If it's written in this form, if both these functions are functions of x, I'm always going to use the quotient rule because it simplifies a lot faster. It's actually less work to use the quotient rule most of the time. Unless the top is just a constant. Then I'd highly recommend doing that, okay? But if you really despise the quotient rule with all your being, you can just do this, okay? When I was in calculus, I skipped the quotient rule at all costs. For some reason, I couldn't memorize it, but I had the product rule down. So that's why I did it. But then it took me a lot longer to simplify. And after being a teacher for a while and teaching it, I've tried it both ways, and the quotient rule is easier. Okay, so 29. That's why I wouldn't rewrite this as x over cosine squared of x, because they've already written it as to the negative 2 power. They want you to use it that way, so I'm just going to do it the way they ask. So, you guys agree that this has two terms? Like this is one term, and then since this is a plus sign, this is another term, right? So when you take the derivative, you have to take the derivative of this thing all by itself, right? And then you have to take the derivative of this thing all by itself. The problem is when you take the derivatives of each one of these things, what are they? What do they involve? What rule? For this one, what rule do you definitely have to use? Product rule, right? Is that clear? Because it's a product. The same thing here. This is also going to be a product rule. All right, so let's get started. So that means this first one, x squared, is going to be f, and this sine fourth of x is going to be g. So that's f times g. So when I take the derivative, f prime g plus f g prime, this is going to be equal to the derivative of x squared is 2x, times the second, which is that sine to the fourth of x, right? Derivative of the first times the second, plus the first times the derivative of the second. How do you take the derivative of this thing? What's the outer function here? So this piece right here. When I take the derivative of this, what's the outer function there? The 4. Good. So the 4 is going to go where? Yeah, I should put it right here. It'd be better, but I'll put it right here now, and then we'll clean it up. So 4, what's that power going to become now? Take care of the 4 first. 4 out front, what goes up in the power? 3, okay. Do you mess with the sign right now? Not yet, right? Sine first. Now we'll take the derivative of the sine, which is cosine of x. So that right there is the derivative of this side, right? I will someday shut my phone off. Just clearly not this semester. Fixed. All right. Plus, I'll write a plus. I'm going to do the other one over here, okay? So this is going to be u, this is going to be v. So I have plus u prime v plus uv prime. I've already used f and g, so I'll use u and v. So the derivative of the first, derivative of x is 1 times the second, which is the cosine to the minus 2 of x, plus the first times the derivative of the second. The derivative of this thing, what's the outer function? Negative 2. So minus 2 something to the minus 3. Leave the inside alone. And what's the derivative of the cosine? Minus sine of x. Okay, now we can clean it up a little bit. So over here I have 2x sine to the fourth of x plus, now what I'm going to do is I'm going to put this cosine, this 4, and this x together, because they all, well, I'd like to say they all have power 1, except the x squared doesn't, right? But what I'm going to do is I start out with this 4, because the coefficient I like to put out front. If it's just a number, I like to put it out front. And then when it comes to x squared and cosine, I like the polynomials to come before the trigs. Because I don't like to say the cosine of x followed by x squared, because you might think I'm saying the cosine of x cubed. And I know they don't multiply like that, right? So what I'm going to do is I'm going to put the x squared next, the cosine of x next, and then I'm going to use this sine cubed last. Now the preference is just mine. It's all multiplication, so order is irrelevant, right? And then I have this one, I have plus cosine to the minus 2 of x. And then here I'm going to put these things together as well. So the x, the negative 2, and the minus sign. So plus 2x sine x times the cosine to the minus 3 of x. We'll do 35 and we're running out of time. I'm going to get to some work in a second here, okay? This is a lot of examples. We gotta do one or two more. So y is equal to x e to the minus x plus e to the x squared. Again, I have a sum, right? So I have to do the sum rule. So that means I'm going to take the derivative of this all by itself, and I'm going to take the derivative of this all by itself, right? Now this left one, what rule do you need over here? Why? Because it's a product. There's a product right there, right? So this is going to be f, this is going to be g, right? So what's the derivative of x? So derivative of the first times the second plus the first times the derivative of the second. What's the derivative of e to the minus x? When I'm looking at this function here, what's the outermost part of that function? What's the outside function? It's an e function, remember? Remember that the input is the inside function, and the thing that's not the input is the outside function, right? Since this is an exponential function, this is its input, right? So that means that's the inside function. Okay, we got to have a conversation. I can tell. Let's talk about two different things, because you guys are getting these two ideas messed up. If I say y is equal to x plus 1 cubed, or if I say y is equal to e to the x plus 1, this is a polynomial. This essentially is born of u cubed, right? Does that make sense? It's just, now I know that where's the variable live? Is it the base or the exponent right now? Where's the variable? This is the base. So this is the inside function and this is the outside function, right? The input's the inside function, the constant's the outside function, right? How about here? Where's the variable? This is the variable, right? So that means that's the inside function and this is the outside function, right? Does that make sense? Remember, when it comes to, it's kind of the difference between saying x squared or 2 to the x, right? This is polynomial, so the input's the base. This is exponential, so the input's the exponent, right? But the roles are reversed, right? Between polynomials and exponentials. So just be careful there. Like, this is the input, and this is the input. So this is the outer function in this case. This is the outer function in this case. All right, so back to work. So, e to the negative x. What's the outside function? E. Good. So, what the derivative of e to something is? E to that something multiplied by the derivative of that something. What's the derivative of negative x? Negative 1. So that takes care of that, right? That's f prime g plus f g prime. Plus, now the derivative of this thing. What's the outer function? E. So the derivative of e to something is e to that something times the derivative of what's inside. What's the derivative of x squared? 2x. So when we clean this up, this is e to the minus x. Negative 1 times x is negative x e to the minus x. And this is going to be plus 2x e to the x squared. So for 81, it's the exact same thing that I did at number 3. So, and then it asks you to plug in a value. So 81 says this. It says f of u is equal to u to the 5th plus 1, and u is equal to root x. And then they say x equals 1. So what they want you to do is they want you to find the derivative of this thing. So I'm gonna rewrite it. It's just, this pen bleeds a lot. So 81 is f of u is equal to u to the 5th plus 1, and u is equal to root x. And they want the value at x equals 1. So they want the derivative of this function at x equals 1. So really, you know that this really is a composition. That goes right there, doesn't it? So it's up to you on how you guys want to do it. If you want to stuff this function in here and say, well, f of x is going to be equal to the square root of x to the 5th power plus 1. You can write it that way. Does that make sense? This says f of u, where this is u, right? So just substituting u in for what u is. Okay, so it's technically f of root x, but whatever. So we just need to take the derivative of this thing. So this is going to be equal to, well, remember that this is a power. This is x. Where's the radical go? Is it in the denominator or in the numerator? So if I say square root, what power is that? 1/2 power. So the square root is 1/2 power. When I say 5th power, it means up here, right? So that is 5/2 power. Does that make sense? It's a square root of, okay, plus 1. So now when I take its derivative, so f prime of this root x, essentially, is going to be 5/2 x subtract 1, so minus 2 over 2, so it's going to be 3/2. Derivative of 1 is 0, right? Now, at x equals 1, this is going to be equal to 5/2 times 1 to the 3/2, so this is going to be equal to 5/2. That make sense? All right.